we tell this to him on the video?
Yeah.
Dean, you were told to stop playing hooky. Devin Roth.
Yes.
Square root of x minus 5 equals 14. How do we get rid of the square root? You square it. Very good.
Whoa!
Let's try that again.
No, you can do it.
Now you're gonna have to say hi.
Oh yeah, you're gonna have to come all the way.
Dean, if you're watching the video, you can skip forward a little bit. There we go. Yeah, we do want to square both sides. Do we have to worry about plus or minus in this case? No, because we're squaring, not taking the square root of it. There we go. If we look at B, same idea with absolute value. You want to get the radical by itself. So we will go ahead and subtract 3 to both sides. Just know some of the problems will not come out to be nice whole numbers, so if you get a fraction, you might want to go back and double check your work, but it will happen from time to time. Example number 2 is very similar. The only difference is now we're not looking at the square root, but instead we are looking at the cubed root. Again, get it by itself. Oh, and did you know this is now called the magic mirror? Did I mention that before?
Mm-hmm.
Yeah. I was informed by that by my nephew. Apparently that's a South Dakota thing. And how do I get rid of the cubed root?
Cube it.
Yep. Relatively simple, right? I don't think there's a lot of questions there. Number 3 looks kind of crazy, but it's actually going to work out really nice, because if we say we want to get rid of the square root on the left side, what's going to happen to the right? It's going to end up canceling out over there too, right? So again, my goal is to get rid of the square root on the left, so we square it. But notice if we square the right, not only do we get rid of it on the left, but it also cancels on the right as well. So when you work with square roots or cube roots or fourth roots, whatever it may be, if they're both inside the square root, we have this idea that you can essentially take whatever's on the inside and set them equal to one another. Subtract 4x. In the same step, let's add 15. And the last one. Did I go too fast? Last one, solve the equation, and then it says in prints or quotations, check for extraneous solutions. Yeah, what does that mean? Can we take the square root of a number and come up with -4? Well, if we square both sides, square, square, 16, that is the number that I come up with, it is the number that we derive, but if we go back in and plug it in, does it work out for us? No. Square root of 16 is 4, 4 minus 4, last time I checked is 0, not -8. So in this case, there are no solutions. We could say that 16 is extraneous. Or you can simply say no solutions. Questions?